This is part 2, a continuation of the last problem, where we're looking at the annual rainfall in a certain region that's being approximated by a which is approximately normally distributed by a curve with mean 41.5 inches and standard deviation 5.5 inches. So we're on part B right now, which is what percentage of years will have an annual rainfall of more than 39 inches. And just as for the first part, or part A, I'm going to begin by drawing a picture of just a standard normal curve to help me visualize part B. So I'm going to draw a standard normal curve for part B. And just like before, if we recall from part A, this particular curve has a z value of equal to 0 at 41.5 inches. We also recall that z is equal to 1 at 47 inches. And what are we asked in this problem? In this problem, we are looking for the percentage of years that have an annual rainfall of more than 39 inches. So now we're actually on the left side of z equals 0 right now. 39 inches is over here somewhere, right? So we're actually looking over here at 39 inches. And just as we did with part A, one of our very first tasks is going to be to find the z-score that corresponds to 39 inches. Well, what do we know? Well, we know, first of all, that the distance between z equals 0 and this other z value, well, that's the difference between 41.5 inches and 39 inches. And so if I subtract 41.5 inches minus 39 inches, I get 2.5 inches, correct? So that means that I am 2.5 inches to the left here of 41.5 inches, or 2.5 inches off the mean. I am looking then for all of the years, or the percentage of years that fall on this side of 39 inches. That's enough information for us to go ahead and now solve first for z. So we're first going to find this z value right here. And just like we did for part A, we are going to set up a little proportionality to help us find this value. I am going to correspond z equals something to this distance here of 2.5 inches. And why do I say that? Because I happen to know that 5.5 inches was my standard deviation that corresponds to z equal 1. So that sets up a really nice little proportionality. So 5.5 inches corresponds to z being 1 in the same fashion that 2.5 inches corresponds to z. We're not sure what it is. So we're going to cross multiply, right? We're going to cross multiply to solve this. So that's going to take us to 5.5 times z. 5.5 times z equals 1 times 2.5. Or notice we have z equals 2.5 divided by 5.5. And this should look really familiar to us, right? Why is that? 2.5 divided by 5.5. This is the exact z value that we just got for the last problem, problem A. The only difference is this time we're on the left side of the mean, right? So really, over here on the left side, my z value is actually negative 0.45, right? 0.4545. Over here, my z value is actually negative. Let me write this down here. Let me get a little space here. Whoops. Oh, that was too much space. So hang on. Let me see what I can do here. So let me get rid of a little bit of this. This z value right here that we're talking about, that corresponds to my 39 inches. my z value is negative 0.45, etc. That's the z value here that I'm looking at. And so once we get our z value, we know what to do with it. Once we get our particular z value, okay, we can look on our curve. Now, the fact that it's actually, slow down, Tina, I'm going way too fast. Let me write this out a little more clearly so that we don't have a mess all over the board. But what's happening right now is that I have a z value, and we have a specific z value that corresponds to 39 inches. Because my z value is on the left, or my value point of 39 inches is on the left, that z value is a negative score. So it's z equals negative 0.4545, etc. Repeating. So we have our z value, and what do we do with that z value? Well, now we look at our table. Our table just has positive z values, but that's okay. We're going to take the positive z value that corresponds to this number, 0.4545, and 0.45, this should look familiar, is 0.7364, 0.17364. And recall, that's the area between 0 and our z value. And the fact that it's on the left, well, this is just symmetric to the area on the right. So that's my 0.17364. I am looking for the percentage of years with annual rainfall more than that. And so if I'm putting on my thinking brain right now, I'm saying this is identical to the last problem. I have 0.17364 pertaining to my little yellow shaded area. I have the rest of the graph, which corresponds to 0.5 in terms of area. And so if I combine those two together and add them up, that tells me the total area under that curve, which is 0.67364, which was exactly what we got in part A, right? And so that means then that the percentage of years that have an annual rainfall percentage, 2 decimal places to the right, is the exact same as answer A. It's 67.4%. All right, that was easy. In the next video, we'll do the last part, part C.